Hello, this is a wonderful question. Science, which is physics. I want to teach you this particular question so that you know how to answer questions that do come in an exam. Some of you get to see these things and you are confused. So the question is saying, a spring with its upper end fixed hangs vertically alongside a meter rule. When we are told or when you are given a question to say meter rule, that is 1 meter, that is 100 centimeters. So the lower end of the spring gave the following readings in table C1.1 when various masses were hung from it. So the first question that is given, as you can see, this is telling us to say, state Hooke's law. You need to know how this law states. So without wasting much time, I had to write down this one so that we don't waste a lot of time, because you can even set this one, the answers will come. So this is the one that I wrote here. You say, Hooke's law states that the extension of an elastic object is directly proportional to the applied force, provided the elastic limit is not exceeded. On the graph, show the elastic limit. So you are going to understand this particular phrase, elastic. I've also used there elastic. So we are going to understand these terms even as I get to explain it at a deeper level, or using some graphs after I've plotted that one. Okay, so we've answered this particular question. That is just 1 mark. If you've observed physics, some definitions or all the definitions stating just carry a mark. This is the reason why you just need to get all of them correct. So copy and complete the table for the values of applied force. So values of applied force newtons and extension centimeters produced. This is a question that we are given. So we get this particular table, then fill up all these gaps that are there. If you are not able to see clearly, what you can do, you can turn your phone in landscape so that you are able to see these numbers so well. As you can see, this row that is here, this is a row for what? This one that is here. We are given applied what? Applied force. Applied force. So we need to find the force that is here, force that is there, force that is there, and the force that is there. How do we get to find the force? You need to know that force have got a certain relationship with weight, where we know that weight is the pull of gravity on an object, where we say weight is equal to mass times acceleration. This acceleration is due to gravity. So you can put A or G there. There's no problem. So this is a particular formula that we are going to be using to fill up these gaps that are there. So when we go to the first one, you need to get your calculator. So when I get my calculator here, this is my calculator. I turn it on. So for this one, what is the mass? The mass is 0.2. Then acceleration due to gravity, that is what? 10. So I get the 0.0 to 0.02 times 10. What is the answer? 0.2. So meaning that here I've got 0.2. This is what you need to do. I go to the second one. So we are just getting mass times acceleration due to gravity. I go to what is the mass? If the mass was in grams, I need to convert to kilograms. But since the mass is already in grams, in kilograms, so no need of converting. I move to the next one, 0.04 times 10. What answer are you going to get? 0.4. So I just write 0.4 there. This is what you need to do. This particular question do come in an exam. I don't know if you've observed, this question usually come. This is the reason why you need to get it and understand it. Those of you under my lessons, I'll answer this particular question and I'll give you an exercise. I see how you are going to understand it. So I want you to do more research on this particular part. I answer this, then I give you, I'll post a question in the group so that I see how you are going to answer it. I move there. This is mass. So 0.06 times 10. 10, that is acceleration due to gravity. So that is 0.6. Here, 0.08 times 10, you get 0.8. You are done. These are the gaps that were left for us to fill in. We go now to extension. Extension, how do we find extension? So the way we get to find extension, if the starting point is here and you are reaching there, so if this is A, this is B, this is C, and this is D. So the way we get to find the extension, if this is the starting point 0, have you seen? Then here we've got 2, there 4, here 6, there 8. We need, at A, we need to say 2 minus the starting point. At B, we need to say 4 minus the starting point. This is how you get to find the extension. In this case, have you seen the readings were what? The readings were 12 here. The starting point was, have you seen the starting point was 10. So you say 12 minus 10, you are going to get 2. So this is how we need to fill up that. I go to this one, 14 minus the starting point 10, which is what? 4. I'm going to get 4. This is 16, 16.0. If it's just the same as 16. So 16 minus 10, that is 6. 17 minus 10, that is 7. We are done. So this is what we need to do. We've finished that. How many marks? 4 marks. Just doing this. And the possibility of you finding this particular question in an exam is so high. This is the reason why you just need to know it. We now go to this question that is here. I guess you are able to see how I'm answering this question. I go to this one. Draw a graph of applied force against extension on a graph paper. So you need to get your graph paper like this. This is your graph paper. So you get your graph paper. Have you seen Zambia a standard graph paper? Your name and exam number there. So when you are given a graph paper, the first thing that you need to do, I told you that the graph should be as big as possible. So in this case, what we are going to do, I do this, I just put a line here. I just leave one box this side. So in an exam, you are supposed to use a pencil. Whether it is mathematics, chemistry, any graph work in an exam, we get to use a pencil. So I just do something like this. If you are following, I guess you are following with me and we are moving together just like this. Okay, I do this. Then I know that here, this is the x-axis. Then I know that this one, this is the what? This is the y-axis. I do this. So they are telling me to say that draw a graph of applied force against extension. So against the extension, meaning this extension is on the what? X-axis. This is what you need to know. This is on the x-axis. Then force is on the what? Y-axis. So against what is given, that thing that is given, meaning it is on the x-axis. Draw a graph of mass against force. So force against force, meaning force is on the x-axis. Draw a graph of mass against speed. Against speed. Speed is on the what? X-axis. So against what is going to be given? Against power. That power meaning it is on the what? X-axis. So this is now a title. A graph of force, applied force against extension. I write it here. So I say a graph of what? I've told you that everything you write it using a what? Using a pen. So I'm just using a pen so that you see. So a graph of what? Graph of applied. So I say graph of what? Graph of applied. Graph of applied what? Applied force. I say graph of applied force against. Against what? So I'm going to say against. Against what? Against extension. So this is it. Against the extension. This is what I need to do. So just like this. You know the rule of English. When you write in capital letters, you don't need to underline. But if you write in small letters, you need to underline. I've already told you that here we have what? The force is here. This is the force. Then force which is in Newton. I do this. Then I also have what? I also have here the extension which is in centimeters. So extension like this, which is in what? Centimeters. This is what I need to do. So I'm told to write a graph of applied force against extension. Applied force against extension. So meaning that applied force against extension. This is the x-axis. This is the y-axis. So you look at the way numbers are moving. Have you seen, first of all, we start with the x-axis. 0, 2, 4, 6, have you seen? So you can just say 2 centimeters to represent 2 units. Because 0, 2, 4, 6, have you seen? So you can say 2 centimeters. I will say, okay, on the x-axis, this is a scale. Okay, the scale that we are using on the x-axis. So on the x-axis, we are using 2 centimeters to represent what? To represent 2 units. So if you 1, 2, 3, 4, 5, 6, 7, 8, it is reaching even up to 8. If I want, I can just say 2 centimeters to represent 1 unit. Have you seen 1 unit if I want? So to make sure that it is as big as possible. Why have I said 2 centimeters to represent 1? Because if I put a 0 here, I will say 1, 2, 3, 4, 5, 6, 7, 8. Have you seen? Ending up to 8. The values that are there, have you seen the values? The biggest number is 7.8. It can fit on my scale. So you choose your own scale. So I will say 1, year 2, year 3, year 4, year 5, 6, 7, 8. I end up to there. So like this. You choose on your own. You know that, okay, these numbers that I've picked, they are going to fit on this particular graph of mine. Then you look at the y-axis. Have you seen 0.2, 0.4, 0.6, 0.8? This one is the simplest. So what you are going to do, have you seen the way they are? They are just 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Just 6. So what you are going to do, you say, okay, on the y-axis, I say on the y-axis, what I'm going to do, I'll just say 2 centimeters. This 2 centimeters is going to represent what? 2 centimeters is going to represent 0. What? 0.2 units. This is what I'm going to do, 0.2 units. So that I'll just be moving the 2 centimeters that we are talking about. Maybe if you are confused, the 2 centimeters that I'm talking about is from here up to there. This box that you are able to see, this is a 2 centimeters. So if I say 2 centimeters represent 0.2, so 0.2, 0.4, 0.6, 0.8, then 1 there. If I want, I can say 2 centimeters represents 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, 1. The graph will reach up to there. Have you seen? So you can use that one. The choice is yours, please. Don't say, sir, what if I use this scale? As long as what you've plotted is appearing on the graph, and the graph is not small, like the small on this particular corner, no. It needs to be as big as possible. Have you seen? It needs to be as big as what? Possible. It needs to be that big. So you can use a scale that you are comfortable with. There is no confusions there. I guess you are following. So if I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it will reach even up to there. So I can use any. So I say, okay, here I say 0.2 according to the scale that I've picked. 0.2, 0.4, 0.6, 0.8, then 1 there. Have you seen like this? So this is my graph, the way I've picked it like this. But if you want to get 0.1 so that it reaches, it needs to be very big like that. It should not be small like this. So I start now plotting. I need now to start plotting. How? am I going to plot now? Have you seen the first coordinate? 0, 0. 0, 0, where is 0, 0? 0, 0 is here. I do this. Then the next coordinate, 2, 0.2. Have you seen 2, 0.2? 2 is here, 0.2, it is there, like this. This is what I'm going to do. Okay. Then I go to the next one, 4, 0.4. So 4, 0.4 is there. This is where it is. Then I move to the next one, 6, 0.6. This is the x-axis, the one that is down. You know that a coordinate, when it is written 2, 0.2, this is x, this is y. So we always start with the x value. 6, 0.6. Where is 6? 6 is here. 0.6. 0.6 is there. So here, this is where I need to put that. I guess you are able to see like this. This is it. The next one, 7, 0.8. 7 is here. Have you seen where 7 is? 7 is here. Then 0.8. 0.87 here. I move 0.8. It is there like this. Then I go to the next one, 7.5, 1. 7.5, it is in the middle. I just count. This box contains 10 small boxes. So I count 5. 1, 2, 3, 4, 5. It is here. 1. So I move on this line straight like this. Straight. 1 is there. So 1 is here. So 1, 2, 3, 4, 5. It is there like this. So this is how I've plotted this particular graph. Have you seen? Just like this. I now connect them. You are going to observe that from here, you need to use a ruler. So from here up to there, this is a straight line. I don't know if you've observed. From here up to there, this is a straight line. Have you seen? This is a straight line. But it is at this point that it started bending. It started doing what? Bending like this. Pa, here, started going like this. Pa, have you seen? It started going like that. So this point where it is starting to bend, it means that it has reached its elastic limit. So the question that is here, this question that is here, where we are told to say that on the graph, show the elastic limit. Where is the elastic limit? The elastic limit is this point here. So this point that is there, that is the what? That one is the elastic limit. So that is the what? That is the elastic limit. That is what I need to do. So I just say that is the what? Elastic limit, this point. Because here it was just coming straight. So at this point, it has changing. It is changing. It is not directly proportional. Here it was just coming straight like this, showing that it is directly proportional. But it has changed. So since it has changed, it's saying, okay, here from this point where it started changing, meaning that is where the elastic limit started from. This is the elastic limit. It meaning from the definition that we wrote here, saying the extension, Hooke's law states that the extension of an elastic object is directly proportional to the applied force, have you seen, provided the elastic limit is not exceeded. So in this case, the elastic limit exceeded. So meaning it is at, this is the elastic limit. From here, it started going its own way. So this is how you answer this particular question. I guess you've seen how I've answered this question, and this is how you need to do it. Just like this, the same way I've answered it, I guess you were able to follow through. So this particular video is public, and if there is any person interested in starting up lessons with me, this is my WhatsApp number. I'm not saying sending me questions. I've said if you want to start your tuitions, you want to register for tuitions, or you want to inquire more, this is the number that you need to text, not questions. Registration, use this particular number. So this is where we end from. Don't forget to like. Don't forget to comment and let me know where you are watching me from, my students, and those of you that are just bumped into this particular session. Share with your friend, like this particular video, and don't forget to subscribe to this particular channel. Thank you so much.